why the Pacific Ocean might be radioactive. In 1903, Marie Curie, her husband Pierre, and Henri Becquerel were awarded the Nobel Prize in Physics for their discovery of radioactivity. At the time, they had no idea how harmful their experiments with radioactive material could be. Exposure to radiation eventually cost Marie Curie her life. Since then, we've learned just how horrible the effects of radiation can be, sometimes through painful historic lessons. But have we nonetheless failed to keep the danger at bay? This is Unveiled, and today we're explaining why the Pacific Ocean might be radioactive. Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more fascinating content. What exactly is radiation? Well, some chemical elements, such as uranium, are inherently unstable due to an imbalance of protons and neutrons. In order to become stable again, an unstable atomic nucleus ejects particles in the form of radiation. There are elements that do this in small amounts all around us in the rocks, soil, and our very own atmosphere. Fortunately, it's not enough to cause us lasting damage. But in larger doses, or with prolonged exposure, radiation can be very dangerous. Some forms of radiation can ignore physical barriers and endanger large areas, such as what occurred in the Chernobyl disaster in 1986, when a reactor meltdown spread radiation throughout the region. Radiation can knock electrons from our cells and harm our very DNA. High doses can cause radiation burns, sterilization, and cancer. The higher the dose, the more lethal. So why would we want anything to do with such elements? Well, at the same time, radiation provides us with a convenient source of energy. Isotopes like uranium-235 are so unstable that they continuously release energy and are perfect for nuclear fission. Uranium-235 also takes 700 million years to shed half of its energy, otherwise known as its half-life. Just one pellet of uranium can create the same amount of energy as 1 ton of coal or 149 gallons of oil, so it's easy to see the advantages. Nuclear power plants are created to harness this energy. Nuclear reactions in their cores are used to heat water and create steam, which then spins turbines and generates electricity. The same process is part of nuclear bombs, either through nuclear fission, in which an atom's nucleus is split, or nuclear fusion, in which 2 atomic nuclei are combined. When a nuclear bomb detonates, 15% of the energy released is radiation. But how could any of this radiation reach our oceans? Nuclear weapon testing peaked in the 1950s and 60s, fueled by the Cold War between the United States and Soviet Union. This included extensive testing by the US in the Pacific. In 1954, US testing of thermonuclear weapons at Bikini Atoll in the Marshall Islands went horribly wrong. Castle Bravo's yield was 2.5 times what scientists expected, and fallout spread over the Pacific, causing radiation sickness in the residents of Rongelap and Utirik atolls, and the crew of a Japanese fishing vessel. The Pacific was also a favorite testing ground for the French, ending only after widespread protests in 1995. All this testing introduced small but detectable levels of cesium-137, a radioactive isotope, into the Pacific Ocean. These levels got much worse, however, on March 11, 2011, when Japan was struck with a massive earthquake and tsunami that killed almost 16,000 people. These tsunamis also happened to hit the Fukushima Daiichi power plant on the coast. Unprepared for a tsunami of this caliber, the power plant suffered a level 7 nuclear meltdown. Although the power plant had backup generators, they were damaged by the tsunami, crippling the plant's cooling system. When unchecked, the temperatures inside the core can grow extremely hot, so hot that they begin to melt. In the case of Fukushima, 3 of the 6 reactors went into meltdown. When this happened, they leaked radioactive water into the Pacific Ocean, causing the levels of cesium-137 to spike dramatically. There's a scale called the INES, the International Nuclear and Radiological Event Scale, used to communicate the safety and significance of radiological events to the public. It ranges from 1 to 7, 1 being a minor anomaly and 7 being a major accident. Experts classified what happened at Fukushima as a 7 due to the high radioactive releases over the days that followed. Some of the radiation is still detectable all the way across the ocean, off the west coast of the United States. Fortunately, the amount present is too small to pose a health risk. Swimming in the water every day for an entire year would still be 1,000 times smaller a dose than a dental X-ray. But another concern is the marine life in the area. Immediately after the meltdown, around half of the region's entire fish supply was deemed above the government's seafood radiation limits. That number has dropped significantly over the years, but 1% of the region's fish remain too dangerous to eat. To this day, the food produced in regions around Fukushima are still being actively checked for radiation. Despite the increased amounts of waste and concerns for safety, there exists no US agency responsible for measuring the radioactivity of the ocean. There's one to check the food and water, but not the ocean, a core foundation of much of the world's food supply. Luckily, as far as we know, the Pacific Ocean isn't radioactive enough to harm us. However, the accident could have had drastic consequences for the environment, as the radioactive waste deposited into the bottom of the Pacific Ocean will remain there for decades to come. Given such disasters, it's worth asking, what would the consequences of severe radiation in the ocean be? In short, the effects would be catastrophic, as it would disrupt the entire food chain. Sure, people would no longer be able to swim in the water either, but that would be the least of our worries. Fish would be the first to feel the effects, forced to live in the radioactive soup. Animals that depend on fish to survive would soon follow. That would make them dangerous to eat in turn. Around 10% of the world's population depends on fisheries for their livelihood, and being unable to fish would be devastating for many. Even worse, around 4.3 billion people depend on fish for 15% of their animal protein intake. It would take decades, if not centuries, for the environment to successfully recover. Luckily, it hasn't ended up that way so far, but there are still detectable amounts of radioactive material in our waters, and we can't be completely sure how much of the environment was really affected by nuclear bomb testing and the Fukushima power plant meltdown. And that's why the Pacific Ocean might be radioactive. What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.